Okay, so this is a review of the Chapter 12 homework problems. First, number 9. Covalent bonding occurs between molecular and covalent network solids. Which statement best explains why these two kinds of solids differ so greatly? Well, remember that covalent network solids are huge molecules that are stuck together by covalent bonds, whereas in molecular solids, they are held together intramolecularly by covalent bonds, but then they have intermolecular forces of attraction that hold them together. So for example, in H2O, we have covalent bonds right here, but the things that holds H2Os to H2Os, these are intermolecular forces and are much weaker than the covalent network, covalent bonds that hold together big, huge molecules like diamond. Number 10, silicon, a fundamental component, integrated circuits, and has the same structure as diamond. Is silicon molecular or a metallic or its covalent network? And if you remember that these guys on the periodic table right here are silicon, carbon, maybe a little bit of boron, maybe germanium. Right in here, this area are the ones that form covalent network solids, and it's only those elements. So when you see those elements making big, huge structures, you know that those are the covalent networks. Silicon dioxide, also another covalent network solid, big, huge molecule held together by covalent bonds, really high melting point, really solid. Number 12, which types of crystalline solid characterized by each of the following? So in letter A, high mobility of electrons are metals or metallically bonded things. Letter B, soft, relatively low melting points. Usually you think of molecular things as that, but it could be some metallic things as well. Letter C, high melting point, ionic. And then letter D, network of covalent bonds. Network of covalent bonds. So that would be covalent network substances there in 12D. I don't know why it doesn't say covalent network right here for 12D. Then on to the next page, number 69. Next problem. If you wanted to dope a gallium arsenide semiconductor to be an N-type, remember N stands for negative, which means you want more electrons. What would you replace gallium with? So looking on the periodic table, gallium right here with the arsenide, so those are the two that are together. And you want it to be an N-type semiconductor, so you'd replace some of these with something that has more electrons than it. The closest nearby relative would be this GE. Maybe you could choose silicon as well. Either one of those has one more electrons. So GE or silicon to replace a few of those. Number 70, if you want to dope gallium arsenide again to make it a P-type semiconductor, remember this is positive. You want an element to replace arsenic, what would you pick? So since you want it positive, you want one with less electrons, one less electrons than arsenic. And if you look at arsenic on here, to have one less electron, you choose either germanium or silicon right here, one of those two. Moving on, number 77. What's a monomer? Well, that's a repeating small unit of a polymer. Which molecule can be used as a monomer? Ethene would be a good example of that. So that would be your C2H4. And then this would have a bond that breaks, and then it would form a polymer with more of those H4s over here, because one of these would open up and bond with it as well. In addition, polymerization reaction. Number 82, write the balanced reaction for the formation of a polymer versus condensation reaction. So here's one big long scary molecule right here with an C double bond OH at the end. And then here's another molecule with an N with an H right here. Be an unshared pair of electrons in this nitrogen. be unshared pairs of electrons, of course, on these oxygen. This H and this OH would go and they would form H2O. And then the C would bond with the N right here, and you'd end up with this C double bond O N to H linkage right here, and it would make lots of these in a row, because you see on the ends, on each ends right here, it could do that again and again and again. So there's the equation. Last two, 97 and 98. Which statement correctly describes the difference between graphene and graphite? Letter B. Graphene is a single sheet of carbon atoms, and graphite may contain many and larger sheets of carbon atoms. And then in 98, what evidence suggests that buckyballs are actual molecules? Letter E is actually the correct answer, more than one of these, and B is true. They have well-defined atomic structure and molecular weight, and C, they have well-defined melting point. Good luck with your Chapter 12 problems.